Alright, so for our last naming review, let's cover naming acids real quick. So real quick, just real general, again back to Gen Chem 1, naming acids. An acid is a compound with an acidic hydrogen or with acidic hydrogens, we could say. So some examples of some compounds and some not compounds, because students often get this confused, is a compound would be something like H2SO4, where you have a +2 charge and a -2 charge to balance each other out. So this is a compound, not any kind of ion. Where if we look over here, we just have HSO4 minus. We know that to be a polyatomic ion. That would be bisulfate or hydrogen sulfate. So a polyatomic ion is not a compound because it has a charge. Compounds do not have charges, they're balanced out. They have their ions balanced out in equal proportions. All right, another example, H3PO4, where we have a +3 and a -3 charge to balance each other out. H2S, where we have a +2 and a -2 charge, again, to balance each other out. Where in contrast, we could look at like HPO3 -2. Again, not a compound, it has a charge. This is a polyatomic ion. This would be biphosphite or hydrogen phosphite. Here we have dihydrogen phosphite. Again, another polyatomic ion with a charge, so not compounds, compounds. All right, now our naming acid rules. So if the compound ends with an "ide", so if you have something like chloride, sulfide, nitride, anything like that, it's going to go to hydroic acid. And so if we had chloride, it would go to hydrochloric acid. If we had sulfide, hydrosulfuric acid. All right, ite will go to us acid, and ate will go to ic acid. So let's go ahead and work some examples to kind of see what we mean by that. All right, and I think we'll be able to keep that in view while we work these examples. Perfect. All right, so first one, HCl. So we know Cl to be chloride, hydrogen chloride. So ide is going to go to hydro, whatever it was attached to, ic acid. So we had chloride, so that will go to hydrochloric acid. Notice how the IDE changed to IC, and we added hydro on it. All right, H2S. Here we have hydrogen sulfide. So hydrogen sulfide, sulfur, and that would be sulfide like we just said. So ide goes to hydroic. So hydrosulfuric acid. I don't know why my spelling just got so off there. Okay. Then we have H2SO4. All right, so SO4 we know to be a polyatomic ion, sulfate. Up here we see 8 goes to ic acid, so sulfate here will go to sulfuric. Notice how this one is different from this one here, but they almost seem the same. If I covered up that hydro there, they would have the same name, but because of that hydro, that differentiates this compound from this compound. So that's why I put these examples right next to each other. If we look at the next one down, here we have PO4. We know that is the polyatomic ion phosphate. So that's going to go to 8 to ic, phosphoric acid. All right, if we come up here, HNO3, NO3 we know to be nitrate, 8 to ic, so nitric acid. All right, if we look down here, HC2H3O2, C2H3O2 we could recognize as the polyatomic ion acetate. So acetate, 8 goes to ic, so acetic acid. Also known as vinegar, just kind of a fun fact. Okay. H2CrO4. We might remember from that polyatomic ion sheet, CrO4 is the polyatomic ion chromate. So chromate, 8 to ic, chromic acid. I really should have used some ite examples. I didn't realize how many 8s I did. That's my bad. But here we have one right here. So if we look at BrO2, so we remember BrO2 to be the polyatomic ion bromite. So again, ite to us, So bromite, so that would go to bromous acid. All right, BrO4, we remember that to be the polyatomic ion per bromate. So the 8 is going to go to ic, but we have to make sure we keep that per there, because if we didn't, then it could just be BrO3. We wouldn't be able to know if it was BrO3 or BrO4. So the per differentiates this from BrO3. So per bromic acid. And that's all. All right. Thank you for watching.